Hello everybody, hope you're doing well and thanks for joining us for another video. Currently in the realm of flat earth, one of, if not the biggest talking point is Antarctica. Mainly due to Will Duffy and his final experiment, which I'll be taking part in December by going to Antarctica to observe and document whether there is a 24-hour sun like the globe predicts. This seems to have really ruffled the feathers of the flat earth community. Several seemingly now starting to turn on each other, and many coming out and trying to argue that the existence of a 24-hour sun wouldn't disprove flat earth, although being unable to explain how it would actually be possible. And also then not only claiming that a 24-hour sun existing wouldn't disprove flat earth, but happy to then say that the lack of one would disprove the globe. Some have argued that the way to prove the globe with Antarctica would be to travel in a straight path across it from one coast to the other through the South Pole, saying nobody's ever done that. Well, unfortunately for them, they have. And there are many other aspects relating to Antarctica that cause problems for the idea of the Earth being flat, not just the 24-hour sun. I mean, for a long time, flat earthers tried to claim you couldn't even go to Antarctica, that you couldn't go any further south than 60 degrees latitude. They've drifted away from that now, but say that you can only go to certain strict places and that you're not allowed to freely explore Antarctica to see what's there because the Antarctic Treaty apparently forbids it. Which isn't true. Granted, you can't just rock up in a boat unannounced and then travel as you please. The treaty was brought in to protect the environment there, so you do need to apply for a permit from your government, namely so that they know that you aren't going to be going and presenting a major environmental problem. And in reality, Joe Public is not really able to just go and explore Antarctica freely without having a major environmental impact, because the place is bloody huge. Antarctica is larger than the entirety of the United States, and there are no 7-Elevens there to stock up on supplies. But as we'll see going through this video, lots of people have actually gone to Antarctica for many reasons. I mean, there have been marathons held there, but mostly people go there to research and learn things. Although you don't need to travel all the way to Antarctica to research and learn. Thanks to today's sponsor, Brilliant.org, you can learn about maths, science and computing from the comfort of your own home. With topics suited to every ability, there is something for everyone. Just pick a topic, start learning, and test yourself with questions as you go. I personally find their use of interactive animations makes the topics a lot easier to understand and much more engaging. My daily streak continues, now being up to 468 consecutive days. And I'm currently on a probability course about going viral on X. And they have new courses being added all the time. So why not see if you'd enjoy Brilliant as much as I am by taking a 30-day free trial, visiting my link brilliant.org/Dave McKeegan, and doing so will entitle you to 20% off an annual subscription. Now, arguably one of the most famous people relating to Antarctica is Robert Falcon Scott, who ventured there twice, first leading the Discovery Expedition from 1901 to 1904, where they travelled to within about 530 miles of the South Pole. And then in 1910, he led the Terra Nova expedition, where he and 4 others managed to reach the South Pole on January 17, 1912, although all of them unfortunately perished in bad weather on the hike back to the camp. However, when they reached the South Pole, they discovered a Norwegian flag had been planted there a month prior by Norwegian explorer Roald Amundsen, who Scott knew was also trying to reach the pole as well. How does any of this relate to flat Earth, you might ask? Well, Scott's journey started from the UK but made several stops along the way, the last one being New Zealand. Setting sail from Port Chalmers on November 29, 1910, he arrived at the Ross Ice Shelf on January 4, 1911, and landed at McMurdo Sound. So 36 days sailing south from New Zealand, 4,000 kilometres. The Norwegians' journey, by comparison, set out from Norway on June 3rd, 1910. Sailing south, they stopped at Madeira, which is a small Portuguese island in the Atlantic just north of the Canaries. Then, sailing from there in July 1910 and sailing south, they landed in the Bay of Whales January 14th, 1911. So they had 6 months of sailing. But the Bay of Whales and McMurdo Sound are both on the Ross Ice Shelf, only a few hundred kilometres from each other. In fact, some of Scott's team happened upon Amundsen's camp while sailing along the coast to explore other areas of the continent. So let's just consider the implications of all of that. Scott takes just over 1 month to sail from New Zealand south and lands at the Ross Ice Shelf. Amundsen takes 6 months to sail south from Madeira and yet winds up just up the coast from Scott, meaning on a flat Earth he would have had to have sailed all the way round to past South America and then sailed a huge loop round to the other side of the world. Even if we say there was no suitable places along the way for him to stop before the Ross Ice Shelf, that is still well over 6 times more than Scott sailed. So he would have had to have been travelling at some crazy speeds, even though his ship was rated 1 knot slower than Scott's. Even then, once they then landed, they were just over 600 kilometres apart from each other. Both teams set out just heading south, and yet both wound up arriving in exactly the same spot. That makes sense on a globe because heading south for long enough will always bring you to the pole, but south on a flat Earth just radiates outwards, so they should have actually ended up moving further away from each other. And this was back in 1911, nearly 50 years before the Antarctic Treaty. After Scott's journey to the South Pole, though, nobody would go there overland again for 46 years, until January 1958, when Sir Edmund Hillary and Vivian Fuchs both led teams as part of the Commonwealth Trans-Antarctic Expedition, which did cross Antarctica from coast to coast via the South Pole, just as some flat earthers have requested as proof of the globe. Side note though, I do think it's funny that a lot of people claim the moon landings were faked because it's not been done again in 55 years, yet it took 46 years to trek to the South Pole. But anyway, the Commonwealth Trans-Antarctic Expedition ran from 1955 to 1958, again before the Antarctic Treaty was signed. This expedition consisted of 2 teams, one led by Fuchs, which sailed from the UK to Antarctica, setting up camp at Varsel Bay, which is south of South Georgia. And around the same time, New Zealand explorer Sir Edmund Hillary set out with a team from Wellington, New Zealand, landing at McMurdo Sound, which is the same place that Scott's team landed half a century earlier. Their task was to lay supply drops from their camp at McMurdo Sound to the South Pole for Fuchs's team. So Fuchs's team would set off from the Antarctic coast near South America. Hillary's team would set off from the coast near Australia, both setting off around November 1957, and both reached the South Pole around 2 months later in mid-January 1958. Fuchs's team then continued along the route back that Hillary had taken, arriving at McMurdo Sound on March 2nd, 1958. So it took them about the same time to travel from the coast near South America to the pole as it did to get from the pole to the coast near Australia. Again, fits the globe, but is severely wrong for a flat Earth map. And this isn't the only crossing of Antarctica. Between 1979 to 1982, Sir Ranulph Fiennes led a team on the Trans-Globe expedition, circling the entire globe through the poles, going only on land and sea, no flying. They set off from London on the 2nd of September 1979. They crossed France, Spain and the Sahara, then sailed round to South Africa and then on to Antarctica on the 22nd of December, and they arrived on the 4th of January 1980. They reached the South Pole on the 15th of December, then a week later set off for the Ross Ice Shelf, reaching it on January 11th. They then sailed to Australia by April 1981, on to Los Angeles by May, sailing around the north of Alaska to get to the Arctic, reaching the North Pole in the April of 1982, across to the other side of the Arctic, and then back to London by the 29th of August 1982. Almost 3 years exactly. In 1997, Norwegian explorer Bjørg Osland became the first person to travel solo across Antarctica. In 2010, Cecile Skog and Ryan Waters managed the first unassisted, unsupported crossing. The same year, there was the Moon Reagan crossing, which used the first biofueled vehicle to reach the South Pole. In 2012, Felicity Ashton was the first person to ski alone across it, using only muscle power, as well as being the first solo woman crossing. And probably more that I've missed off. Although all of these seem to have taken fairly similar routes between the Weddell Sea and Ross Sea, and I'm sure flat earthers will probably try and pull up the lack of ones going across the other way. So for them, there is the 1990 International Trans-Antarctica Expedition, which was a 6,000-kilometre trip involving an international team of 6. 1 American, 1 Brit, 1 French, 1 Russian, 1 Chinese, and 1 Japanese team member. They travelled from the Antarctic Peninsula to the South Pole, then carried on to the Soviet Voskov station, and then finishing in Murnay station. So plenty of expeditions, completely across Antarctica, and done in times that all conform to the globe's version of Antarctica, and yet make absolutely no sense on a flat Earth map. Speaking of which, this brings us up to a recent video by Taboo Conspiracy, where he claims that the French yacht racer François Gabard, in an interview, essentially let slip that the Earth is flat.
Et un tour du monde en bateau, c'est très très simple. Hein. Oui. On descend l'Atlantique, on tourne à gauche à chaque fois, et puis on tourne. Comme si on faisait le tour d'un lotissement. Enfin, je veux dire, il faut toujours tourner à gauche. Si on hésite à un moment donné, il faut tourner à gauche.
Ça, c'est extraordinaire, ça.
Taboo is inferring that Francois' statement about having to keep turning left means turning left around the edge of a flat Earth, whereas on a globe, he says you'd be constantly turning right. Except I would argue that is not what Francois is referring to. Now, Taboo only includes a very short section of the interview, so I've managed to track down the full version, but obviously it's in French, and I know petit pois about speaking French. So I've uploaded it to YouTube as an unlisted video, the link of which will be in the description down below, so you can watch it for yourself and use YouTube's auto-translate if needed. It's not a perfect result, but just before the statement about having to keep turning left, there are several mentions of Cap Horn, which I believe is supposed to be translating to Cape Horn, the southern tip of South America, and how he didn't actually see it, but it was a relief to reach it because it meant that they were at the end of the South Sea and then that they were turning left to head home. I think what he's referring to with the statement about keep turning left is the waypoints that they reach. They sail from France, they turn left. They head down the Atlantic, they reach the South Sea, they turn left. They sail around Antarctica until they reach Cape Horn, they turn left again and back to France. Now, Taboo is arguing that this includes whether they keep turning left or right to sail around Antarctica, but I would argue it doesn't. Earlier in the interview, Francois talks about how they navigate, that he doesn't use celestial navigation to work out his position, that it's all done with GPS, even highlighting that they have an autopilot system. But if we ignore the autopilot and assume he's steering himself, they're in the middle of the ocean. There are no landmarks visible for reference, so the only source of guidance that he'd have are GPS coordinates. And the South Sea is not exactly calm, so the boat's direction will constantly be changing both ways. So on neither model would it be a steady constant turn either left or right, but rather turning in both directions to combat the sea. The only definitive turns that they'd make on either model are at the waypoints. Now, yesterday I received an email from Walter Bislin, who's done a lot of work comparing the globe to flat Earth, And he actually has the GPS data from some of the participants in the 2020 Vendée Globe race and showing the route and speeds taken around a globe, which also included a link to the official tracking map for the race. And you can see the race has an exclusion zone around Antarctica. This is in place to avoid the risk of racers going too far south and coming across icebergs, but the zone isn't a perfect circle. So on a globe, they wouldn't constantly be turning right anyway. You can actually see that as they pass Cape Lewin, the zone moves out further south and all of the racers move south to hug the edge of it. Now that makes sense on a globe because the further south you go, the shorter the distance you're traveling. On a flat Earth though, that means that they're moving out to take a longer route. The more logical path for a racer on flat Earth would be to pass north of the Auckland Islands. Then again, the rules for the Vendée Globe race only state that the course is to keep the 3 capes to the sailors' port side and the Antarctica exclusion zone to their starboard. Nothing more than that. So if the Earth were flat, the more logical route for the racers would be to hang left after New Zealand and cut straight across to Cape Horn rather than hugging all the way around the outside of Antarctica. However, let's consider the distances involved. The race is stated to be around 44,000 kilometers from start to finish. Although, because there's no definitive racing path, the distance does vary slightly. But Francois took 11 days to sail from the start line to the equator, then reached the Cape of Good Hope 12 days and 3 hours after that, reached Cape Lewin 11 days and 7 hours later, then a further 17 days and 20 hours to reach Cape Horn, 13 days and 19 hours to get back to the equator, and then 12 days back to France from there. Mapping that entire route out on the globe gives around the same distance of 44,000 kilometers. So based on a globe, we're looking at about 5,900 kilometers to get from the start line to the equator, which he did in 11 days. That's about an average speed of 22 kilometers an hour. Cape Lewin to Cape Horn on a globe is just over 10,000 kilometers, and Francois sailed it in 17 days and 20 hours, which makes for an average speed of around 23.8 kilometers per hour. So they're fairly consistent. Now let's look at the respective distances for flat Earth. Although we don't know the exact distances for flat Earth because none of their maps actually have the distances, and no flat earthers seem to agree on them. So I just drew a line of arbitrary length and I kept duplicating it. Between the start line and the equator, I was able to place just over 5 lines. Between Cape Lewin to Cape Horn is 42 lines, which puts the distance between the capes at 8 times the distance from the start line to the equator. So if we say that the 11 days to the equator is 5,900 kilometers sailed at an average of 22 kilometers an hour, then the 17 days 20-hour journey between Cape Lewin to Cape Horn would be 47,000 kilometers. That makes for an average cruising speed over those 17 days of 110 kilometers an hour. Average. That's the sort of top speed of many speedboats. I'm sure some flat earthers will be thinking along the lines of there being really high speed winds all the way around the edge of the world that can account for the difference. However, during the race, Francois set a new solo sailing record for the distance covered in a 24-hour period with an average speed of 22.3 knots, which is 41.2 kilometers an hour. That was his peak average over a 24-hour period, and the race took him 78 days. So at no point did he manage a prolonged average speed faster than 41 kilometers an hour. So if we say, okay, maybe he was doing a steady 41 kilometers an hour all the way around the edge of Antarctica, there was 29 days and 3 hours between him rounding the Cape of Good Hope to him reaching Cape Horn, which is 699 hours. So at a steady speed of 41 kilometers an hour, that would make the race route around most of the edge of flat Earth to be just over 28,500 kilometers. And that route actually goes pretty much perfectly through 18 of the 24 lines of longitude, meaning the distance between each line of longitude that far out would be about 1,580 kilometers. So the full circumference of the world would be around 38,000 kilometers. That would give us a circle radius of 6,047 kilometers, or 3,757 miles. So from just off the coast of South Africa up to the North Pole would be 6,000 kilometers. And the AE map has 9 lines of latitude, meaning the gap between each would equal 671 kilometers. The UK takes up around 3/4 of one of those, which would make the UK about 500 kilometers from north to south, rather than the almost 1,000 kilometers that Google Maps states. You know, suddenly walking from Land's End to John O'Groats doesn't sound too bad. It would also mean that there's 3 lines of latitude between France and the equator. That would equal about 2,000 kilometers, which Francois took 11 days to sail, meaning he would have had to have been sailing at an average speed of 7.5 kilometers an hour for those 11 days. The average walking speed of a person is 5.1. 7.5 kilometers an hour is a jog. The typical sailing speed of a sailboat is 5 knots, or 9.8 kilometers per hour. So they'd have to be sailing intentionally slow on a flat Earth to take 11 days to reach the equator. And some of the participants took over 2 weeks to get there. That seems a bit counterintuitive in a race. Anyway, that's going to wrap it up for this video. As always, feel free to leave your thoughts in the comments below. If you've enjoyed this video and you haven't already done so, then please consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.